Welcome back to Logic, Language and Information, and to this, the last lesson in the series on propositional logic programming. We will briefly touch on negation in PROLOG. From what we've seen so far, PROLOG has no direct way of handling negative information. We can load up a program, pose a query positively, and then get a negative answer to a logical consequence question, which might tempt us to conclude that somehow the negation of the goal in the query might sort of follow from the program. But be warned, this is dangerous and wrong. In this case, we cannot conclude the negated goal formula is a logical consequence of the program. Many implementations of PROLOG, including our recommended one, SWI PROLOG, have additional syntax allowing the expression of a negated atom in a goal for query. The negation symbol is \+, roughly the opposite of positive. The purpose of the syntax is to give a way to ask whether the positive query will fail. That is, to flip the polarity of the query. Negation in queries is best seen in an example. Consider the logic program involving 4 atoms, P1, P2, Q1, Q2. Its clauses are P1 if Q1, the tautology P2 if false, the fact Q1, and last Q2 if P2. Let's query the 4 atoms in turn. First, the query for P1 is answered true, which should be clear from the program clauses P1 if Q1 and the fact Q1. Next, the query for P2 is answered false. The only program clause with P2 as its head is the trivial P2 if false, so resolution will hit a dead end here. Next, the query for Q1 is answered true, and the query for Q2 is answered false, as resolution will also hit a dead end. Now, let's try the query for \+ P2. This negative query is answered true precisely because the positive query for P2 is answered false. That is all the negation symbol means in PROLOG. Likewise, the query for \+ Q2 is answered true because the positive query for Q2 is answered false. But caution is required because PROLOG with this restricted negation operator is no longer sound for logical consequence. Let P be the program listed in neg001.pl on the previous slide. A goal G is a logical consequence of P exactly when, for all truth valuations V to the atoms, if V makes all the clauses in P true, then V also makes all the atoms in G true. Now suppose V is any truth valuation that makes all of the clauses in P true. It then follows that under this valuation, or in this row of the truth table, both P1 and Q1 must be true, or must be value 1. This is because of the P clauses, P1 if Q1 and the fact Q1, are both true in this valuation. So, at the level of semantics, we can see directly that P1 and P2 really are logical consequences of the program. However, from the program clauses P2 if false and Q2 if P2, from their being true under a valuation, we cannot conclude that that valuation must value P2 and Q2 as false. That is only one of several possibilities. Evaluation V that values P2 and Q2 as both true is also possible, as it will also make both those program clauses true. A different valuation that values P2 false and Q2 true is another possibility, as this one also makes both those program clauses true. So, the negated formulas, not P2 and not Q2, are not logical consequences of program P. And in addition, the positive goal formulas P2 and Q2 are not logical consequences of program P as well. In summary, the negation symbol in PROLOG extensions should be approached with caution. It is only to be used within a goal query preceding an atom to ask whether the positive query for that atom will fail. Unlike true answers for standard positive queries, a true answer to a negated query does not allow us to conclude logical consequence for the negated atom. Further treatments of negation in PROLOG extensions use a concept called the closed world assumption, or alternatively go into what's called non-monotonic logics, but these are beyond our scope. This brings us to the very end of the series on propositional logic programming. I hope you've enjoyed this short introduction to the theory and practice of automated reasoning.